Okay, this is Advanced Math Set 83 Simple Probability, Independent Events, and Replacement. So first of all, we'll review probability of an event. Probability is the number of outcomes that are what you want out of the total number of outcomes in the sample space. Okay, so for example, if you're rolling a die and you roll it once, what's the probability of rolling a 5? Well, there's 1 5 and there are 6 total outcomes. So your probability is 1 out of 6. The probability that you get something greater than 4, it's not equal to 4, it's greater than 4. There are 2 probabilities, 5 is bigger than 4 and 6 is bigger than 4. So it's 2 out of 6, which is 1/3. Okay, now you have 2 fair dice that are rolled. What's the probability that you get a 7? And what's the probability that you get something greater than 8? The easiest way to do a problem like this is to set out a table. So set up a table with both possibilities where you have one die going down and then you have another die going in the other direction. So the probability, whoops, I didn't let that finish. Okay, so the probability that you get a 7, you have to find all of the 7s in the chart. And we count them up and we get 6 out of the total possible, which is 36. There are 36 possible outcomes. So reduce that and you get 1/6. Okay, what's the probability that you get a number greater than 8? Okay, this time we're looking at everything bigger than 8, not including 8. Count them up, and you get 10 out of 36. Reduce it, and you get 5 out of 18. So the probability of rolling 2 dice and getting a number greater than 8 is 5 out of 18. This kind of a chart is really helpful if you play Settlers of Catan and you want to figure out the probabilities. Okay. Now, probability is always between 0 and 1. Most of the time when we talk about probabilities, it's a percentage, and if you think of percentages as being 0 through 100%, and then if you're talking just about the decimals, it's just from 0 to 1. So, an example of this is, what is the probability of getting a 146 when you roll a die? Well, obviously you can't roll a 146, so the probability of that is 0. You can't have a negative probability. Probability of getting a number less than 146, well, all of these numbers are less than 146, so that's 36 of them out of the 36 that are less than 146, which is 1. And like I said before, you can't have a probability that's a decimal or a negative number or something like -3.5. Just won't happen. Okay, so now we are going to talk about independent events. Independent events do not affect each other. So you have 2 people that are both tossing coins. One person's tossing a nickel, one person's tossing a penny. They could both be tossing pennies. They could both be tossing nickels. Doesn't matter. The fact that one person is tossing a coin doesn't affect the outcome of the other person's coin toss. They don't depend on each other. Okay, so now we're going to talk about tree diagrams. Tree diagrams are really helpful when we are talking about coin tosses and when we're talking about independent events. So you can fill out, this is for tossing a coin 3 times. So you can see here's the first time, here's the second, and here's the third. And I'm going to erase that just because I don't know what I wrote after this. Okay, so if we want to find, or you can see that there are 8 possible outcomes. Some examples of outcomes are you could get heads and then heads and then heads. You could get heads and then tails and then tails. You could get tails and then heads and then tails. So those are 3 examples of outcomes. And in fact, the way that you can tell that there are 8 possible outcomes is because there are 8 circles in the last row on the 3rd coin toss. Okay, so what is the probability of getting heads and heads and heads? So the probability of getting head and then heads and then heads is 1 of the 8 outcomes. Another way to look at it is look at it individually. You can say the probability of getting heads the first time is 1 out of 2. Then getting heads the second time is still 1 out of 2. And then the third time is still 1 out of 2. So it's 1/2 times 1/2 times 1/2, which equals 1/8. Okay, so you have a fair coin that's tossed 4 times and comes up heads every time. What is the probability it will come up heads on the next toss? Think about it. It's a trick question because every coin toss is independent. Because even if you've tossed a coin and it comes up heads 100 times, the next time you toss the coin, it still has a 50% chance of coming up heads and 50% chance of coming up tails. So the probability that it's going to come up heads on the next toss is 1/2. Always, always, always. It is independent. Okay, so now that we talked about independent events, we'll talk about dependent events. So you have marbles drawn at random and replaced. The second marble is randomly drawn. So what is the probability of getting a black and then a black? So you pull out a marble. That wasn't a black one, but this is just an example of replacement. So you pull out a marble, it gets replaced. So the probability of getting a black the first time is going to be 2 out of 4. Now, the second time is also going to be 2 out of 4 because it was replaced. If it was a black one, the black one got replaced, there's 2 blacks out of 4. So that would be 1/2 times 1/2, which equals 1/4. So the probability is 1/4. If it's replaced, there will always be 4 marbles to choose from. Okay, now we're going to switch it up just a little bit. What's the probability that you get a black and then a black if they're not replaced? So you take out a marble, and again, my drawing is wrong. You pull out a black marble, it's not replaced, it changes. It's best to think of it with a tree diagram, although we'll do it algebraically in a second. So here's a tree diagram to help you understand. So you pull out, okay, so you have 4 marbles in the jar. 2 of them are going to come out black and 2 of them are going to come out white. So we just have an equal chance of getting black or white, so it's just shown by 2 branches on the tree. So the probability that you're going to get a black on the first one is 1 out of 2. Okay, now you took a black one out, so there are left 1 black and 2 whites the next time. And so what's the probability of getting a black on the second time? Well, there's 2 ways to look at it. You can look at all 6 of these and you can say that event happened 1 out of the 6 times, or you can look at it individually. You can look at it as, well, the first time I drew a marble, there was a 1/2 probability. The second time I drew a marble, it was a 1 out of 3 probability. If I multiply those 2 events, then I'm also going to get 1/6. Okay, 2 cards are drawn at random from a 52 card deck without replacement. What is the probability the first one is red and the second one is black? So there are 52 cards in the deck, so we know that the first one is going to be out of 52. And we have to think about how many are red and how many are black. Well, half of the cards are red, so 26 of them are red. Now, if you don't replace it, then there's going to be 51 on left for the second time you draw. Okay, so we know 26 are red out of 52, and now we're going for out of 51 cards because it wasn't replaced. So what's the probability this one is black? Well, we didn't pick a black one the first time, we picked a red one, so all of the black ones are still in the deck. That means there's going to be 26 left, And now it's just a problem of simplifying these fractions. So the first thing we can do is we can cancel. 26 goes into 52 twice, and then 2 goes into 26 13 times. So the probability is going to be 13 out of 51.